Hi everybody, and welcome to the second in the series on the rocks of Donegal. Behind me here is a section of the coastline at Malin Head made out of quartzite. Now, quartzite is a metamorphosed sandstone. In other words, it's been baked hard and put under immense pressure from all sides until it recrystallises into the one great big chunk of rock. Now, some of the bands in the rock behind me here may have started out several metres thicker than what they appear to be nowadays. It's that massive compression during the mountain building process that shrinks everything down. What we're actually looking at behind us here is a section of quartzite that used to form a part of an ancient beach, and in some cases the quartzites in Donegal were also made from seabed sands that have been compressed and thrust up. This, however, is a section of that old beach I was mentioning before. The rocks have been compressed, heated, and then thrust up onto their edge, similar to what's happening in the Alps at present, where the rocks have been broken and then turned up onto their edge. And here you can see that play out very, very well. It looks like a mini model of sections of the Alps. You can also take a look at the rocks in the far distance there. They appear very blocky in nature the further away from them you get. It's like looking at Minecraft in reality. What's actually happening there is that little faults and tears in the rocks that have been created after they've been solidified, recrystallised and then thrust up cause weaknesses that are exploited by both ocean and ice and wind and rain, and eventually they break the rocks down. They break away in these solid, very, very uniform chunks. Quartzite's one of the most noticeable examples of a metamorphosed rock, and it's one of the most common. Like I said before, silica is one of the most common substances on the face of the earth, and quartzite's 99% silica pretty much. It's like glass, basically. Sand baked hard, turned into a glass-like rock. It's incredibly tough material, and it resists weathering very, very well. So these have been here for millions of years like this, survived ice ages, droughts, all manner of things, and ourselves today with our big feet traipsing all over them. Now, later on in this series I'll also be talking to you about some of the features you find within these rocks, but for now, taking the view behind me here, it's one of the nicest examples of metamorphic rocks, and we'll be showing you some more caves built into those there at a time to come, and showing you the rock up close as well in the next clip or two. Here we are on the top of the Donegal Mountains on one of the flanks of Muckish Mountain, so named because its back looks like the back of a great big black boar that rises up out of the countryside. What we're looking at here is a scree slope, which is a very, very steep slope on the side of a mountain that contains eroded chunks of rock that are all quite unstable. So for any of you who are not familiar with hill climbing in any way, don't climb on this stuff. You'll either go through it or it'll go over you. Always try and go around it if possible. The rocks that we're looking at here are examples of the layers that have been sheared away either through ice coming over the mountain in the ice ages, or freeze and thaw action in winter times, getting in between the layers of the quartzite, which are the only real weakness in this rock, and breaking it off, and then it's tumbling down the mountainside. Each one of these pieces has a razor edge. It's incredibly sharp. That's because Muckish in particular is one of the purest examples of quartzites anywhere on the island of Ireland. This stuff in some places on the mountainside is almost 98% pure silica, which is really, really rare. It doesn't occur very often in nature at all, but we have it here, sitting on it right now. This particular lump that I'm holding here is covered in lichen and moss that grows at these higher altitudes in the hills, and the problem with that is it makes identification difficult. If you have enough lichen and moss on the surface of any rock, you could be looking at a piece of sandstone instead of a piece of quartzite or a piece of granite and vice versa. The only way to make fully sure is to mix and match your evidence. So when you're looking at it, look for areas that don't have any lichen on it, like this rock here, and you begin to see the base colour of the rock, which is actually a fairly clear sort of a white sandy colour. Like I said before, quartzite is a metamorphosed sandstone. This started out as a beach. So looking at this here, you see the actual colour of the sand that once made it. This stuff has been baked incredibly hard. We're basically sitting on a mountain that's made of glass. It's very, very tough. Now, to the back of the camera here, if we can get the camera to pan around for just a second, you can see the rest of the mountain range going out behind us. There's granite mountains off to the left, but the mountains directly behind the camera in this shot here are all made of quartzite, and they all have that layering throughout them. You can actually see it at a distance in some cases. Now, this material, like I said, is incredibly hard and tough, and one of the advantages of this as a building stone, for example, is that it will never ever wear away. If you build a decent wall out of this, it will stay there for generations. Some very, very fine examples of cottages built out around the Ardra and Columcille region have stood for hundreds of years without change, because the rock is, like I said, it comes out of the ground ready as building stone. Understanding how the stuff is formed is part of the wonder of this rock. The mountains that we're walking over today with this made of this rock type will probably remain unchanged for millions of generations to come. So that's a little bit about the quartzite there. The main points to remember is it's incredibly hard. Be careful when you're handling it because it's edged, it's effectively glass. It's been baked sand, and it comes away in layers, which is its only real weakness. That's how it erodes in the first place at all. It takes a very, very long time to erode. For further information on this rock, just type in quartzite into Wikipedia or Google, and an awful lot of information is going to come up. But it's always good to go out and find examples of these things in reality and actually get a feel for the material itself. In the next little clip, I'm going to show you some of that layering on one of the mountain sides here. The layering I wanted to show you, this is a road cutting next to Mount Derryveagh, which is further down the road again from Muckish, 2 miles as the crow flies. There's an awful lot of red tinting in this rock here, just because the quartzites here are full of iron and other minerals. There's a little bit of manganese thrown in there for good measure as well. You can clearly see now, there's the bottom bed of some of the layers. There's the top of the bed there, and there are these well-defined chunks that used to be layers of sandstone that at the bottom of this, at the bottom of an ocean or at a beach. And just to show you here on camera, this stuff clipping away, very, very glassy, and that kind of sugary sort of effect there. That's what you get through quartzites the world over. That very, very sugary looking effect. This is where the silica has actually melted out of the sand as it's being compressed, and then reformed into this very, very tight glass-like crystal structure. So this stuff, again here, this was blasted away to create the road, which is why we get such good definition here on the layering, and we don't have too much soil overbearing it as well, so you can get a good look at it. Further over here, you can see the layers in the side of the hill. They're in a step-like pattern. The one thing you need to be careful of when you're looking at the layers is, are they actually the right way up? Because quartzite occurs in an awful lot of mountains that have experienced folding and faulting, sometimes the layers can get completely flipped over. If you take a look at the top of a bed, usually you'll see a ripple effect, which is left over just like any beach around the world, left over when waves come in and lap up against the sand, creating a ripple. That denotes the top of the bed. If you're finding that underneath here, then the beds have been flipped. If you're finding that on the top of the beds, 9 times out of 10 when you're looking at a rock surface, then you know that it's still roughly the right way up with respect to folding and faulting. So that's a little bit about it here, and just with the faulting, everything's at a nice slant here as well. It looks like a set from an old Batman movie. It'll show you a good example of how everything gets thrust up onto its edge during the tumultuous mountain building processes. So the last thing we're going to leave you with in this video here is a glimpse of the next type of rock we'll be talking about off in the distance here. That's the Poison Glen out there, made of granite, and that's the heart of the Donegal batholith there. Very, very strong, very, very tough rock, and we'll be showing you a little bit more about that during some of the talks on the physical geography of Donegal and getting up in there into that gigantic playground. But for now, I hope all's well with you, and I'll talk to you again soon. Goodbye.